My name is Dave Test. My day job, I'm the Learning Space Technologies Manager for Penn State University. So I manage the tech in the classrooms and labs there. But my passion and my hobby is vintage computing, personal computing in particular, and I love the Raspberry Pi. So we're going to talk about how to get your favorite computer up and running on the Raspberry Pi. So who doesn't know what a Raspberry Pi is here? Everybody familiar? Okay. So Raspberry Pi is a series of small board computers developed in the UK by Raspberry Pi Foundation to promote the teaching of basic computer science in schools in developing countries. So the goal of Raspberry Pi Foundation is to make the smallest single board computer at the cheapest price possible to further education goals in the UK specifically, but also worldwide. Right now there's basically two models. There's actually 5 or 6 models that are shipping right now, but these are the two that are sort of the most useful. Raspberry Pi 3B Plus is the most powerful version of the Raspberry Pi right now. It's got these specs, and it's plenty fast. It can run anything, from everything in 1977 up to probably mid-90s. Once you get into the sort of 32-bit, it sort of, it edges out, but it's a very, very capable system. It's about the size of, a pack of cards. Raspberry Pi Zero W is a very small version. It's much smaller than a credit card. And it's also fairly powerful. It can run everything probably up to the 16-bit era. The main thing is this one is $35 and this one's $10. So you can get into this for very, very inexpensively. So Raspbian is the main operating system that's supported by the Pi Foundation. So it's a variant of Debian Linux, so it inherits all of the things we get from Linux, but it's officially supported by them. There are plenty of different operating systems you can run on the Raspberry Pi. You can run Windows, you can run Ubuntu, you can run Android, you can run Plan 9, you can run all sorts of things on there. But Raspbian is the one that they officially support. So why do we want to use the Raspberry Pi for emulation? Well, there's a couple of reasons. As I said before, it's cheap. $10 for the Pi Zero W, $35 for the Pi 3B Plus. It's sort of hard to beat that price in the single board computer market. It's reasonably powerful. The Raspberry Pi 3B Plus right now, in real world speeds, benchmarks are all crazy. You can fake them 1,000 ways, but in real world practice, it's about as fast as a 1.8 gigahertz Intel Core 2 Duo. So sort of put it in like mid-spec 2009, 2011 laptop speeds. And it runs Linux, and it has an ARM processor. So ARM CPUs are in almost every smartphone. In fact, I don't know if there's a smartphone that doesn't have an ARM CPU in it at this point. And it has broad code compatibility with Linux because it's running Debian Linux. Those two things combined mean if an emulator was written for Android, chances are it's going to work on the Pi with a little bit of modification. So let's get started. There's really 3 paths in doing emulation on the Raspberry Pi. The first one is to install Raspbian and then manually install, configure each emulator. You can use apt-get, the package manager on Raspbian. You can install each one, configure them to however you like, and run it just fine. You can use a pre-built image and customize it as needed. So a lot of people make different little pre-built images that you put on an SD card, put in there, and some of the hard work's been done for you. And then there's something called a bare metal emulator. A bare metal emulator is not necessarily running an OS on top of the Raspberry Pi. It's code that's specifically coded for the hardware of the Pi. So you're not running a program that's then running on the Linux kernel that's running on it. You're running program that's running directly on the silicon on the Raspberry Pi. What we're going to talk about today is the second path, which is a pre-built image, and it's called RetroPie. So RetroPie, pre-configured Raspberry Pi image focused on game system emulation. So these are all of the emulators out of the box, all of the systems out of the box that RetroPie supports. So there's quite a few there. And if you look carefully at that list, there's a lot of computers in that list. Again, it's focused on game system, but In the 80s and 90s, and even currently, arcade machines, game consoles, they're running the same chips. 6502 is in the NES, it's in the Apple II, 6510 is in the Commodore 64. So once you have cycle exact emulation for one of those chips, it's pretty easy to write an emulator to take advantage of all the other features of that computer. So in RetroPie, there's over 100 emulators available. There's 19 of them configured pre-configured that can run 8 and 16-bit computers. That's out of the box. It has MAME and MES, which MAME was the sort of the original arcade emulator. They did a lot of the hard work getting the cycle exact emulation right on a lot of these commodity chips that were also used in computers. MES used to be a separate project. Now it's a part of the MAME project, and it's focused on emulating basically as many things as possible. So HP calculators, those little Tiger handheld electronic games. Like it's really impressive the number of things it supports. And then libretro and RetroArch, those are sort of a more modern implementation of emulator. libretro is basically an API set, and RetroArch is a front end, and together it lets you write what they call a core. So you can write a Nintendo core, you can write a Vice core for Commodore emulation, you can write a Dreamcast core, and you plug it in there, and then all of a sudden that RetroArch can take advantage of that. Emulation Station is the GUI that runs on top, the front end that runs on top of RetroPie, and it gives you a nice interface and manages the controller mappings, things like that. So it makes it easier. So when I set up RetroPie, I configure my controller, I configure my keyboard, and then it configures all the emulators it supports for me. I don't have to go out and say, well, for these 14 emulators I want to run, I have to go in and manually configure every single thing. There are some things that you're going to have to get up and running by hand, but it does a lot of the hard work for you. One of the things I want to keep mentioning is Emulation Station and RetroPie in general is a game launcher. It wants to have a list of ROMs or a list of games. You go to that emulator, you click that ROM, and then it boots straight into it. But a lot of computers, especially from the sort of vintage era, they don't do that. They boot into a basic interpreter, they boot into a command line. So there's some things that you have to do to sort of tell the emulator, I don't want to run a game right now, I want to boot into the system. So you can do things like a 0-byte file, that just says, you load that into the emulator, and the emulator is immediately like, oh, well, I'm just going to boot in BASIC, or some stuff like that. Proper file extensions. So RetroPie is almost completely controlled by what the file extension is on the thing you're trying to run. So if it's a Commodore 64 disk image, it needs to be a D64.D64, because that's how Emulation Station RetroPie say, oh, that's a D64 image. I'm going to put it in the interface. I'm going to run it using the Commodore 64 emulator. There's also PAL and NTSC issues. I don't know issues, but there's things to be aware of. So PAL runs at 50 hertz, NTSC runs at 60 hertz. There's plenty of games and software that run on 60 hertz and runs on 50 hertz. And when you have a system that can do it all, you run into issues where there's a new cool game that comes out and it's written in PAL, you're running in NTSC mode, and best case scenario, the program is self-aware and it can determine that timing and it knows how to run correctly. Sometimes it just crashes because the timing it needs too critical of a timing, and the 50-60 it just doesn't work out. Or sometimes it just runs really fast because you're running at 60 hertz instead of 50 hertz, so it's a little bit too quick for it. So your game's going to run 10% faster or however much it was. And each emulator you can sort of configure and say, I want to be in PAL mode, I want to be in NTSC mode, and we'll take a look at that when we go through the emulators themselves. So, I was here in 2017 and I did a Raspberry Pi demo, and it never worked because the demo gods were not shining on me that day. But we're going to give it a chance again the day, and I think we're going to have better luck. So there's three things I want to look at in this demo. The first is the RetroPie documentation, because this is really the gold mine. This is really something that's going to save you a lot of time getting these emulators up and running. Then we're going to look at the RetroPie setup script. The setup script is the brains of the RetroPie. It's the thing where you manage all the emulators, you manage the configurations, So we're going to take a look at that. And then we're going to look at some different emulators, just different things that you can get up and running and how to do that, little caveats for each one. So let me switch my HDMI cable over here. And we'll see what happens. Is anything going to happen? So I'm running, I have these two little cases here. These are both made by a company called RetroFlag, and they're really cool. This one looks like an NES. No, and this one is a Super Famicom, a Super Nintendo. And what I really like about these cases is that they have intelligent power buttons and reset buttons. So I have this later on in the slides, but we can talk about it right now. The Raspberry Pi doesn't have a power switch. As soon as you plug it in, it's on. As soon as you take the power out, it's off. And if you have a mounted file system running while that's happening, especially if something is writing to the file system and you pull the plug, bad things can happen. So what these basically do is there's a little header that plugs into the GPIO pins on the Raspberry Pi, and then there's a little script that runs. So when I hit this power button to turn it on, it turns it on. When I hit the power button to turn it off, it's looking for that contact closure on the pin, and it says, oh, that pin was triggered, run this script, and the script will safely shut down the machine. The reset button does the same thing, except instead of just immediately resetting it like a hard reset, it runs a script that says, okay, properly bring down the system and bring it back up. So it just saves you from problems, because otherwise it can be a little bit tricky. So this is Emulation Station. So this is running on RetroArch. Think of RetroArch as sort of the, for lack of a better term, the OS, even though it's Raspbian running. RetroArch is doing the hard work here, and Emulation Station is what you're seeing here. So you can see I have TRS-80, Amiga, Apple II, Atari 800, Atari ST, Commodore 64, Tandy, Macintosh, MS-DOS, and ports, which actually runs the Raspbian desktop. So the first thing that I want to look at here is the RetroPie setup script. And I think I set this font so that it should be big enough for y'all to see, but no, I did not. So let's go in here, and I'm going to set that to a nice chunky font. There we go. Is that a little bit better? Okay. Still might be a little bit hard to see, but at least we're not in the room with a tiny TV, then it would be impossible for everyone to see. So, like I said before, this is the RetroPie script, setup script. This is where all of the administration things in RetroPie happen. So, for example, managing packages. So if I go into Manage Package here, so one of the main packages is RetroArch itself. So that needs to be installed. Emulation Station needs to be installed. The RetroPie menu, and then Run Command. Run Command is a little piece of middleware software that when you click on Emulation Station and say, I want to run this, Run Command takes over and runs the appropriate emulator, and then it brings you back to Emulation Station when you're done. If we look in the main packages, so these are all of the emulators that come by default installed on RetroPie. So we have a bunch of MAME, we have Atari, I don't even know what that is, Neo Geo, Final Burn Alpha, Game Boy, Genesis, different kinds of MAME, NES, so a lot of different things here. So these are the things that are installed. If you never boot into this at all, these are the ones that are going to be installed. So you can configure those right out of the box. That's pretty cool. There's quite a few of them there. There's also optional packages. Now these are packages, these are emulators or little tools for RetroPie that they've tested for the integration that works properly, the code base is properly updated, that sort of thing. So these aren't by default installed. You'll see I installed the Atari 800 emulator and the DOSBox emulator, but there's just so many of these things too. So you can have an MSX emulator. You can have a PSP emulator. You can have SCUM VM emulator, so you can run all of your LucasArts games. Thank you. Stella for Atari. UAE for Amiga, and it gives you a little bit of a description down there at the bottom to say each one of these. And like I said, these are the vetted, like officially supported but optional emulators on here. I'll just keep going down through. And then you get into things like, here's a Quake 3 port, bunch of different sort of open source reimaginings of games. So there's a whole bunch of stuff here. There's a scraper installed. So the scraper is something that when you run Emulation Station and it sees all of the things that are available for the emulator that you've chosen, by default it just gives you a piece of text to say this is the file name basically. But if you run a scraper can go out to the web and basically say, let's say you're running, I don't know, Oregon Trail on the Apple II. It can go out and it can pull a screenshot of Oregon Trail. It can pull the publisher info, the date, and a little description, and then it makes the interface a little bit prettier. When you go to Oregon Trail, it gives you a little splash screen that says, here's all about Oregon Trail. That's what a scraper does, and there's a whole bunch of different scrapers on here that talk to different services and do different things. USB ROM service, this is a really cool thing. So getting the ROMs or disk images or whatever you're doing on the RetroPie, there's two easy ways to do it basically. The one way is when you boot up the RetroPie, if it's on a network, it makes a bunch of Samba shares. So it makes one called ROMs, one called BIOS, one called configuration. And each one of those shares has a folder in it for the emulator that you might want to use. So let's say you want to emulate a Commodore 128. So in there, there's going to be a folder for C128. You put your disk images in there. The next time you start Emulation Station, those disk images will pop up. What the ROM service does, it lets you do that over USB. So you format a flash drive, FAT32. You make a folder on the root of that flash drive labeled called RetroPie, one word. You plug it into the Raspberry Pi, and what it does is it makes a folder structure on that USB flash drive with all of those folders on it. So as soon as that's done, you unplug it, plug it into your computer, put in all the disk images and ROMs you want into all of the folders that you want to emulate, plug it back in, and it'll ingest all of those correctly. So that's pretty cool. So you can then keep a backup of that or keep an archive of it. So the next time you configure a new one, all you have to do is plug that back in. It'll copy everything that it had onto that again. So you don't have to reinvent this every time you want to build one for a friend, because as soon as you make one of these and you show somebody, they're going to want one, and so you're going to have to make this over and over again. I know that from experience. Driver packages in here, these are sort of custom things. Like if you want to run a PS3 controller wireless on here, you can do that. A Steam controller, Xbox, that sort of thing. These are just little driver packages that let you do that easily. And then there's the experimental packages. And the experimental packages is really interesting because these are emulators and tools that the RetroPie community is aware of, and they work well enough to compile and kind of do what they want to do, but they haven't really been vetted by the community as a whole, or they might be so new that no one has had a chance to put them through their paces yet. So, run through here, there's, like I installed Mini VMac, which is a small Mac emulator up to System 7, I believe. SDL TRS, which is a TRS emulator, T99A. So if you had a T9994A, you could use this to run that. I have internet access, so I can't actually do this, but if I tap that, it says install from source or package help. If I go back to another one here, let's try this guy. No, that's the same one. Because that's already installed, it had a remove on it. What I wanted to show you was, if I go to one, let's see, this one. No. Huh. I'm looking for one that says install from binary, because there's two ways to install any of these things. And I'm just picking the wrong ones. But anyway, there's basically anytime you do these installs, there's two ways to do it. There's a repo of all of these vetted emulators on a RetroPie server somewhere, and there's a binary version, and then there's source code. And the advantage of installing the binary is that it's usually much faster. It just downloads the executable, puts everything in the right places, and then you're good to go. The advantage to the source code is oftentimes more up to date. So what it does instead is it downloads the entire code package, it compiles it natively on the Raspberry Pi, and then it installs it. So using the binary can sometimes tend to get you a more stable emulator, but it might not have as many features on it. Running from the source will get you like either a nightly build or a dev build or something that might have more features. Okay? So that's basically how the packages work. Configuration tools. This is where I went in and I changed the console font to be something a little bit bigger for y'all to see. So that's one of the things in here. I can edit my Bluetooth bindings. I can change the theme for Emulation Station. Change how those Samba shares work. Change the splash screen when I boot up. Configure Wi-Fi. So this is just sort of where you go to do configuration for RetroPie. Update RetroPie script is important. Excuse me. If you go to the RetroPie website right now, you'll download the image of RetroPie that's version 4.4. That was made like October or like March of last year. And you might think, well, is this project even actively being updated? Well, it is, because that 4.4 image is 4.4, this is 4.412, which had its last commit 8 days ago. So what happens is you download the main package, or main installer, you install it, and then you update it, and it pulls in the minor revisions since then. So as you can see, it's been 8 days ago, so it's pretty actively maintained. And then you can, like, if this is the first time, you can download this, you can install Raspbian on your own terms, and then download this install script and install RetroPie on anything. You don't have to use the pre-configured image, although it's a little bit easier. In that case, you would install or uninstall. And then you can do a reboot. So we're going to go back to Emulation Station here. So get back here. So within here, this RetroPie, this is sort of the hub for doing little things. Configuring the Wi-Fi, showing the IP, things that are maybe a little bit easier via a GUI interface. You can do all of these things through that setup script as well, but they're a little bit easier to access here. So let's dive into an emulator. So you might not be able to see the red in there quite as easily, but this emulates a DOS, an x86 PC. So popping up, and there we go. So I have the full access to that. I can go in here. Whoops. I can go to Word. Whoops. Sorry, I'm typing. Standing up is always a strange endeavor. So there's the most exciting thing you would ever want to emulate, of course, which is, I think, Word 5 for DOS. But that's a good example of that. So that was basically launching straight into the command line. But I could also, I can create a link here for every one of the files that I'd want to emulate. So if I had a specific game or specific application that I wanted to boot directly into, I have one here for a game called Cannon Fodder, and I have one here for Word. If I hit that, it just takes me into that same, into the folder for that, and then it'll just launch it directly. There you go. One of the other things I should mention is when I go in here and I hit Start DOSBox, you'll see there's a little thing that shows up and says, press any key to configure this. That's that run command I was telling you about. So when that comes up, if I hit a button, this lets me configure things specifically either for this emulator or specifically for this ROM. RetroPie treats everything as a ROM, even if it's a disk image, even if it's a directory somewhere. In its parlance, it's all ROMs. Okay. So I can set the default video mode. So let's say I wanted to run this in 320 by 240 to get a CGA experience, or I wanted to run it at whatever. I can change that as the default for anything that runs in DOSBox, or I can do it specifically for that ROM. So if I had a game that needs VGA mode, I can set this for that ROM to run in VGA mode. If I have a game that needs EGA or CGA 4-color palette, but it likes the one palette versus the other, I can change that sort of thing through here. I'm just going to go back and say, exit that without launching. So let's go, what am I going to do here? Let's go Commodore 64. So as you can see, I have a couple of different things here. Even though this says Commodore 64, this is the VICE emulator. So I have access to all of the different things within VICE. So I can bring up PET emulator. So that's going to run the executable for the VICE XPET emulator, which is part of VICE. And now I have a PET. Now, I might fumble around a bit with some of these things, because all of them have a different keyboard shortcut for getting to the menu of it. So forgive me if I fumble around a bit here. But that's going to be pretty hard to see. But you can see I can do things like I can attach a disk image to different drives. I can change the drive settings, so I can say, well, that drive 8 has more expansion memory. So there's all sorts of crazy things you can do with that. What's that? I don't know. Just that command? Oh, I don't know. So just type wait 6502? What should that do? Oh. Oh. Wait. Space. Uh-huh. Uh-huh. Any number here, or just hit enter? Oh, okay. Man, I don't see that there. So VICE is sort of the most, there's a couple different Commodore emulators out there. VICE is really the one that's the most sort of battle-tested, battle-hardened. It's been around for a long time. I believe that the C64 Mini is actually running a bare metal version of VICE with some customizations on top of it. So, yeah. I can change the screen mode. I can make screenshots. I can change the CPU settings. So there's all sorts of things I can do in here. We'll get out of here. We'll launch into C64 mode. Now I'm in C64. And I have those same options that look a little bit easier here. So, I can bring up a monitor, virtual keyboard on the screen, change all the different sound settings. Yeah. So, that. Oops. And then I have a couple of different things here. So, this is a cartridge program. This is a D64 image. I don't have to wait for it to load, but I'll at least show you how that works. So, when you have a D64 image, it'll boot and it'll just immediately execute the command to run the command everybody knows. So it's going to load it, and right now that's running in real time. If I speed up the drive, it's probably going to break it, but I can go in here, and if it's a disk that is working, that supports a faster transfer mode, you can change all the sort of drive settings and everything like that, so you can make it as fast as you want it to be. I'm just going to boot out of that. And so, yeah, so that. Let's boot into something with a GUI. So let's run a Mac. So this is running an emulator called Mini VMac. I think Mini VMac runs System 1 through System 751 or something like that. So I think this might be a 701 image. And as you can see, I have full keyboard and mouse control. And just like a Mac. Wow, look at that. Clip art in a text file. The future is here. I mean, applications here. So take a trip down memory lane, run Norton Utilities, Yeah. Yep.
Will this run acceptably well on a zero?
This is probably stretching the limits of it, you know, because this is 68,000 16-bit. You know, it can run, you know, like some of the later Macs are 020s, 040s, so you have a 24-bit or 32-bit address. You can run those, but that's really where you start sort of edging out of the ability of the machine. Yeah. So, okay. And this one is, I think, so again, in this particular emulator, you have speed control, you control different settings. So each emulator has its own nuances, so you sort of have to get used to how that particular emulator's interface works. But they're all, you know, they're all designed to be fairly helpful. That one, in fact, because I hadn't properly shut the system down, it actually warned me. It said, "Hey, you didn't quit out of the system here, so you know I might corrupt your disk image," and that's fine for this case. I can't even see what that says. Well, let's boot in here. I think this is the Cocoa. Yeah. So this is going to launch extended color basic for the Cocoa. You know, so I could do. Whoa. You know, so I could do all the fancy things you can do on the color Cocoa. And I know it's thrilling. So again, finding which button is it that pulls up the menu that I want to be, and that's. Yeah, exactly. That is one of the nice things about the RetroPie is that it's pretty quick to reset. So, in fact, I think we might be in that situation. So let's see. Let's see if the script does what it's supposed to do here. Yep. So I hit the reset button on this thing, and now it's shutting down Linux, and then it's going to reboot back into Linux. If you have any questions while this is, yeah? So the question is, can RetroPie run as a VM? So you can run a Raspberry Pi simulator on a modern computer, but you can't really easily emulate the Raspberry Pi because it just takes too much demand for that. But what you can do is there's a version of RetroPie for x86. So you could have an x86 VM and you could run RetroPie on that and it would work fine. Yep. You're not going to get all of the same emulators because some of them are specifically compiled for ARM, some of them are specifically compiled for x86, but the bulk of them are about the same. Yep.
Now, your RetroPie
Yeah.
and your emulation station, you can install those just with an apt-get or
So the question is, yeah, how do you install this? So the way that I did it was I went to RetroPie's website and I downloaded an image, put it on an SD card, and then it's already there. But you can go to the Raspbian website, download that distro, and then once you install Raspbian, you can then use apt-get to install RetroPie from there. So however you want to do it.
Is it easy to add a game ROM?
Yeah, so either using the USB, like I talked about, you just put it in the folder, pop it in there, and it immediately adds it. Or you can get to it over the network. Yeah, it's really easy.
will this work with any Raspberry Pi?
It will there's two distros of RetroPie as a pre-baked image. There's one that works on the Raspberry Pi 0 and the Raspberry Pi 1, and then there's one that works on the 2 and the 3. So you just got to download the right one. And the different things will work differently. Like the Raspberry Pi 3B Plus can kind of do, you know, Nintendo 64 emulation, things like that. The Raspberry Pi 1, 2, and 0 can't really do that. So it just sort of, one's optimized for the more modern set, one's optimized for the other set. And as I was saying, there's also an x86 version of RetroPie. So if you have an old PC laying around, you can install RetroPie on that as well. So yeah. Let's try. We'll boot into a TRS-80 Model 1. All right. So let's see here. We'll in file directory. We'll see what that disk looks like. I don't think you'd ever see that quickly on an actual Model 1, but there you go. So that's there. I know, yeah. It's not the full authentic experience, is it? Yes, yes. So the question was, does it have like shaders for emulation? And it does. Boy, I'm really feeding back. So let's go into what has a good shader. Let me try Apple II here for a second. You know, I tried booting into that Amiga thing, and it worked at my house. And now it just shows me the Workbench thing, so I'm not sure exactly what's going on with that one. So here we're loading. Okay, so we can go, let's see, HDR. So all these different modes. In this particular emulator, so there I can bring up my file structure. Trying to find, there is a keyboard shortcut. There we go. So let's see if are there any things on here. Cycle through the various video modes. Yeah. Well, yeah, they're doing that, so. But yeah. Yeah, and for the game emulators, there's also things like if you really want your NES emulator to run at 320 by 200, the native of the NES, you can set it to that. Or if you want it to upscale it to 1080p and smooth all the pixels, you can do that too. So yeah, there's a lot of different things. Now, depending on the version you're running, sometimes those shaders will eat your resources. And so, if you're running a Raspberry Pi Zero, and you're emulating a Super Nintendo, I don't know that I'd mess too much with those shaders because you're already kind of maxing it out, but yeah. So let's get back to reboot here. Where's my quit? Anybody see quit here? F10. All right, there we go. Maybe? There we go. And then I can go to Oregon Trail, which again is just booting directly into a disk image instead of booting to the basic interpreter. And again, it's speeding that up quite a bit from what you would normally expect. But yeah, we'll travel the trail here. We are let's be a carpenter, and my name is Dave. So yeah. And we can try the Amiga one, but when I tried to boot, I think what might be happening is, I think right now I have it configured for Kickstart 1.3, and I'm trying to run a Workbench 3.1 disk, which it really wouldn't like that. So it looks at it for a second and it's like, I don't know what that is, and then it goes back to that. So this particular emulator has a nice kind of GUI interface for it. So I can say I want to boot into I want to boot as an Amiga 1200. That might let me mount that disk a little bit better. So now I have the 3.1 ROM. And if I go in here, I'm going to say, where's my disks? Floppy drives. So now if I go into DF0, I can just pick one. And again, these are all going to be located in that folder called Amiga on the USB drive and on here. So anytime I would add any other games or any disk images, that's where they would show up in that interface. So let's see if that's going to pop up.
Also emulates drive status?
Thinking about it. What's that?
It also emulates drive status?
Yes. Mm-hmm. Mm-hmm. Yeah, you can have it turn on the constant noise, the click every 5 seconds, or there we go. And so we have our Workbench here. So yeah. The one of the main code maintainers of RetroPie is a huge Commodore and Amiga fan, and so the Commodore and Amiga support in RetroPie is stellar. It supports a lot of other things, but I have noticed that there's a certain spit shine to the things that are Commodore related. And then because this is running Raspbian, it also has the full LXD and E environment, which is a KDE-like GUI, so I can run a full-fledged GUI on top of this. So, I can run a web browser, and I can get a shell, that sort of thing. So, this is handy. Like, if you're looking for an image, or you're looking for a little script, you don't have to go to your other computer to pull it up. You just boot into this environment, and then you can open up a shell and do what you want to do with it. So I'm not going to be able to get anywhere because I'm not online.
Run it without HDMI, like connected with like say VNC or something?
So you can. The question is, can you VNC? You can VNC into the command line interface, and you can VNC into that LXDE interface. You can't VNC into this because this is running. This is running sort of like I think it's SDL, but it's running like a DirectX or an OpenGL with, so it's not going to give you that access. Yeah. So, I mean, I think we can try Atari SD here. And as you can see there, I had EmuTOS, which is sort of an open source re-implementation of the gem, and then I have TOS, I think the last released version of TOS here as well. So, yep. There we go. And of course, I'm just dipping into each one of these. There's obviously more you can do with every one of them. Just I just got to find the right keyboard shortcut here again. Oh, come on. Might have to reboot again.
The different like option screens,
Yeah.
are they just made to like look like the environment you're in, as opposed to like actually written in the environment?
So on the interface where you see that, is that what you're saying? Like the...
The interface like this shows you the special option screen that's for the RetroPie, but it's internal into
Oh.
Media Atari ST. It actually looks like that same interface. It's not
Yes.
like,
Yeah, usually like the person that's coding that emulator wants to have sort of a holistic experience, so they want to make it look kind of like the user interface of that computer. Yeah.
Is that part of like that libretro that allows you to kind of use from the thing, or
So libretro does provide some consistency. The other nice thing about libretro is when I was saying that, how like, I guess that's another thing we can show here. So if I want to configure a controller, so you sure want to configure an input? Yes, I do. So this is a $10 Buffalo Technologies SNES clone thing. So I can plug this in on the front via USB. If I press and hold a button on it, it says, oh, that's a USB, it's a 2-axis 8-button gamepad. So if I keep that hold down, so now it's basically going to say, what are all the buttons on this? So I'll say, here's up, down, left, right, start, select, A, B, X, Y, left, and right shoulder. Now I'm out of buttons. I don't have any more buttons on here. So what I basically do is you press and hold, and it says not defined. And so having the not defined is pretty much as important as doing the defined buttons, because now all of the emulators that are capable of getting this information will know how these buttons on this device work. So I would say at least 75% of the emulators on here would now be able to use this just right out of the box without having to configure each emulator by itself. That's really one of the main things you're getting from this. The RetroPie and Emulation Station is you don't have to start from zero for every single emulator. You start from a little bit of an advantage.
you have to put into the game config if it doesn't work?
If you if for some reason it doesn't work, you can go into the emulator configuration and you can set it up there. Or sometimes, if it is a game that supports button remapping, you can go in there and set it. But for the majority of them, it'll just use whatever you tell it. The keyboard is actually showing up as a controller as well to this interface. So I have, D-pad up, down, left, and right mapped to the arrow keys. I have enter mapped to A and escape mapped to B. That lets me navigate this without having a thing. But I could just as easily use this to emulate through there. So if you have one of these set up in your living room for doing mostly game stuff, you can just use this to navigate through. So the other thing I wanted to go over quickly is the documentation, because that's really another place where this shines. So I'll go back to my computer here. It can run, the 3B Plus can run some 64 games. The Nintendo 64 is basically right at the edge of the power of the current Raspberry Pi. Super Mario 64 runs great. The Mario Kart 64 runs pretty well. Once you get into the games that were coded sort of later on in the 64's life, it really starts chugging pretty badly. So it kind of works, but it's not the best. I'm going to sit down for a second here so I can more easily navigate this. So because I'm not on the internet here, I scraped the documentation page, so this might look a little bit wonkier than it would normally. But the main thing I want to show you here is if I go into getting started, this is basically going to walk you through every single step here. So it's going to cover, here's the hardware you need, here's how to install it, here's how to configure the controllers, there's the button mappings, here's what Emulation Station does and the RetroPie startup script, transferring ROMs, all the stuff that we just covered. The real gold of this documentation is in the emulator section. So let's say I go into Atari 2600 here. So somebody has basically done all the hard work here. So they're showing you that in emulation, in RetroPie, there's two emulators for Atari 2600. There's LR Stella and Stella. LR means it's the libretro version, which means it'll take advantage of that common configuration for controllers. And you can configure each one, put them however you want. If you put in Atari ROMs, it's going to look for a 7Z, it's going to look for an A26, a bin, a GZ, a ROM, and a zip file. And it's going to look for them in this path. So that makes it pretty clear. If you want to run ROMs, you put them in that path. For the controller, LR Stella, as I was saying, uses the RetroArch configuration. Regular Stella, you would go in and edit a configuration file to do this. It has this for every single emulator on the system. So, I can just as easily go into, let's find a MSX. So if you want to run the MSX computers, there's three of them here. There's OpenMSX, LRMSX, and another one. These are the ROM extensions. These are the file extensions looking for here. Put your ROMs here. Set up your controls like this. Since this is a computer, it needs a BIOS file. None of the BIOSes and ROMs are included because that would be a copyright violation. But it tells you where to put all that stuff to, and even what it's looking for. So in order to emulate the MSX Korean version, you would need these ROMs. To emulate the the Turbo R, you need these ROMs. And again, shows you. So it's standardized documentation. This will save you days versus downloading it through Raspbian and then just trying to figure out where all this stuff is. It's already here. It already tells you exactly what to do. So this saves you. This is a gold mine of information. We'll look at one more here. Let's look at the TRS-80. So there's 4 TRS-80 emulators here, and they all have different advantages, disadvantages. In this case, it's a Model 1, a Model 3, a Model 4, and a Model 4P. So it's always going to look for a .dsk. You put them in here. Here's the BIOS files you need, and even here's the controls. So if I would have looked at these docs, I would have known that those were the F buttons I was supposed to hit for that. So if I go back to my slides here for a second, maybe. Oh, come on, don't be like that. Oh, I'm full screened here. That's what's going on. I'm not a full screen guy, so this often confuses me. Oh, is that all it is? No. Pretty straightforward. So as I was saying before, just a couple of things. Like I said, Raspberry Pi has no power button. So you need to invest in something that has a power button, preferably a smart button. Like I said, these two cases are from RetroFlag. I really recommend them. They're rock solid. They're also making a Game Boy package for the Raspberry Pi Zero that has all those same features built in, so I'm looking forward to that. Buy a good power supply. When I was here a couple years ago, we talked about this extensively, but basically, when you had the original Raspberry Pi and the Raspberry Pi 2, they could run off pretty much whatever USB power supply you had. Once we got to the 3 and the 3B Plus, you really need a good power supply. You need one that can actually deliver 5 volts at 2.5 amps. A lot of them that you buy for 10 bucks from Amazon or eBay will tell you that, and it turns out they're 4.7 at 2.2 volts or whatever. So buy one that's at least 5 volts, 2.5 amps. That'll save you a lot of time in the long road. If you boot up your Raspberry Pi, and especially if you go into an emulator, and all of a sudden you see this lightning bolt in the top right corner of your screen, and especially if it doesn't go away, that means that the CPU is basically underpowering itself because it doesn't have enough power to do what it wants to do. So that's a clear indicator that you need a better power supply. If there's a thermometer up there, it means that it's throttling the CPU because everything's too hot. So in that case, you need some better cooling. Restart Emulation Station after adding ROMs and disks. So if I have it up and running and I'm connected to it over via network and I dump 50 Commodore games onto there, and then I immediately go into Emulation Station and none of them are there, Emulation Station isn't constantly indexing. It waits until it gets restarted. So restart Emulation Station and it'll find all those things. So that's a pretty easy thing to mix up. And then back up your micro SD card. Once you have this installation the way you want, you may never need to mess with it again. So make a good backup of it. Use Win32 Disk Imager on Windows. You can just use DD on Linux or Unix or the Mac, and just make a backup. You can do things like you could have an rsync script that's syncing things back and forth and that sort of thing. But if it's all of these things are running on it. This is an 8 gig SD card because it was the one I had lying around. It would take 5 minutes to back that up. So. Well, as I said, the RetroPie site is your friend. In-depth documentation for every emulator. It tells you the right paths, the right config files, the right scripts. And there's a really good active forum. So if you have a question, you look through the docs, you can't figure it out, post it. Somebody will help you out. RaspberryPi.org. RetroPie.org.uk, that's where you get RetroPie itself. I'm David M. Test on Twitter. And that's all I had. So if anybody has any questions, I'd be glad to answer. Questions? Yeah.
So your systems that are emulated in MAME, for example, how long would that take for that to work its way down to the file?
Like a mainframe emulator? Is that what you're saying?
Well, so recently, I just installed that to the MIPS IR systems were
Yeah.
in MAME.
Yeah.
Kind of wondering how that.
Oh, okay. So the question is like when they add new features to MAME or MES or another emulator, how long does it take to trickle down? For MAME, it can be difficult because the versions of MAME that are running on here are typically older versions of MAME that have an optimized profile for a slower machine. Like if you run the latest version of MAME, it requires a much faster computer because it's built to. It gets more and more cycle exact, and as you get more and more cycle exact, you need more and more power. There's less ROM hacks to make things work in the background. So for something like if MES just added a brand new emulator to it, it might take a while for that to come down to the Raspberry Pi because the Raspberry Pi might be based on MAME.37 or MAME.187 instead of MAME.207 or whatever the latest version is. So. It eventually will get there, but it might be a little bit slow. Things like Vice, things like those emulators that are sort of ported across multiple platforms, those usually come pretty quick because it's either a direct compile of that source for ARM that then runs on the Raspberry Pi, or there's some group of code maintainers that are making a port specifically for Raspbian or specifically for RetroPie to run that. So, yeah. Other questions? Okay, great. Thanks a lot.